Mr. Monahan here, Fun with Proofs answer key. You should have taken this quiz in Schoology already. Use this to correct your mistakes so you can get 100% on it, and then use this to study for the Chapter 3 test this week. First one, number 1, you were proving the alternate interior angles theorem. That's any two angles that are alternate interior, like 4 and 6, have to be congruent if the lines are parallel. That's what these red arrows mean. So the fact that the lines are parallel this time is given to us. What we can start to say is I'm going to look at angle 2, and I'm going to and understand this part as well. Steps 2 and 3 can be in either order this time. So here we have 2 and 4 that have to be congruent. The reason they have to be congruent is because they're vertical angles theorem. The other angle that 2 is congruent to is 6. The reason that 2 and 6 are congruent is because they're corresponding. This angle, angle 2, is the upper right angle in the intersection of L and the transversal, and angle 6 is also the upper right angle where M meets the transversal. So those are corresponding angles. And so technically steps 2 and 3 could have been in either order this time. I think Schoology gave you a certain order for it. And then step 4 is 4 congruent to 6. They are alternate interior. We just can't use that this time because that's the theorem we're trying to prove. So I have that both 2 and 4 are congruent. I'm sorry, 2 and 6 are both congruent to angle 2, which means I have two things that are congruent to the same thing, angle 4 and angle 6. When you have two things that are congruent to the same thing, we know they have to be congruent to each other. This is called the transitive property. So there's your answer for proof number 1. Going on to proof number 2, now we're going the other way. We're doing the converse of the alternate interior angle theorem. So we're going to start by knowing that 4 and 6 are congruent. So these two alternate interior angles are congruent. What we don't know this time, these arrows shouldn't be here. What we don't know is that the lines are parallel. We're going to prove that that has to be true. So again, 2 and 4 have to be the same, congruent because they're vertical angles. They're across the intersection from each other. Then I have two things, 2 and 6 are both congruent to angle 4. So that means they have to be congruent to each other. Again, that's called transitive property. So the type of angles that 2 and 6 are corresponding. Whenever I'm trying to say lines are parallel, it's going to be converse of something. So this time it's converse of corresponding, since 2 and 6 are corresponding. That's your answer for number 2. Check your work and make sure you get it right the second time. Number 3. The first step is blank, so again, we're proving the converse of the alternate exterior angle theorem. So we know that 1 and 7 are congruent. We want to say that means these lines, L and M, have to be parallel. So before we get into how we should do this one, here's the point I want to make for the test. There is no way you should get less than 3 points on this one. 1 point here, 1 point here, 1 point here. You should never get any of those 3 things wrong. They should be automatic. So 1 is congruent to 7, that's given. It's in the picture, they're marked congruent, and it's up here. The first reason's always given. We know we have to end with the lines being parallel because that's what we're trying to prove. So there's only 6 blanks on this one. You should never get less than 3 out of 6 in that situation. So they said angle 3 congruent to angle 1. Here's angle 3, here's angle 1. Same thing we've done in the first 2. Those are vertical angles. Then they said 7 and 3 have to be congruent. You can look at what they are, but that's going to really help us with the next step. There's a pattern to these, as you can start to tell. 7 and 3 have to be congruent because they are both congruent to the same thing. This time they're both congruent to angle 1, which means that angle 3 and angle 7 have to equal each other. They have to be the same as each other because they both equal angle 1. That's again called transitive property. Then we can go look at what type of angles 7 and 3 are. Here's 7 and here's 3. Those two are going to be called corresponding. So converse of corresponding angles. So the proof of converse of alternate exterior is almost identical to the alternate interior converse. That's proof number 3. Moving on to proof number 4. This time we don't know the lines are parallel. We have no reason to say that, so we can't use some shortcuts that would be nice, such as the vocab from this chapter. But here's 1, 2, 3 automatic blanks that we should get no matter what. We know that 1 is congruent to 7. That's marked on the picture. The reason is given. Where we want to get to is 3 and 5, these alternate interiors. We want to say they are congruent. So here's what they told us in the next step. 7 and 5 are congruent. If you look at the picture, there's 7 and 5. Here's 3 and 1 that are also congruent. Both of those are examples of vertical angles. Now they're going to go with angles 3 and 7 being congruent. Well, let's look above at what we know to be true. We know that angle 3 is congruent to angle 1, and we know that angle 1 is congruent to angle 7. So these two angles are both congruent to angle 1. This is, again, transitive property like we've talked about. So since 3 and 7 are both congruent to 1, they have to be congruent to each other. And now that we have 3 and 7 congruent to each other, look at what else 7 is congruent to. So 3 is congruent to 7. 7 is congruent to 5. So 3 and 5 are both congruent to 7. This is transitive twice in a row for this proof. So vertical angles and transitive, if you haven't caught on to that yet. Here's proof number 5. This is something from the 3.4 notes that you would have watched. We didn't do an assignment on. So here's my given. Here's where I want to get to. Here's kind of how we should go through this one then. So in a plane, R is perpendicular, so this means perpendicular. R is perpendicular to T, and S is perpendicular to T. So we have 90-degree angles here and here. That's what the boxes mean. Okay, so perpendicular means right angles. Angle 1 and angle 2 are right angles. That's because this is standing for definition, the definition of perpendicular lines. Remember, in proofs, step 1 should lead to step 2, which should lead to step 3, which should lead to step 4. So we have, since the lines are perpendicular, we have some right angles. That's just what perpendicular means. Angle 1 and angle 2 have to be the same then. Well, if they're both right angles, that means that they're both 90, which means they have to both be congruent since they have the same amount of degrees. The reason for this is all right angles are congruent. Now, if you look at angle 1 and 2, what type of angles are they? They're corresponding, upper right, upper right. So if I want to say something is parallel, I need the word converse, and then the type of angles that we have. Converse, corresponding angles, postulate. Number 6, here's the automatics. What's given? Oh, I guess maybe I don't have given type. There it is. Given typed in. So in a plane, C is perpendicular to B, so there's my right angle. B is perpendicular to D. What I want to prove is if I make this line longer, that C would also be perpendicular to A. Okay, so theorem 3.8 is something from the 3.4 notes. What we would be able to do is say since these two are perpendicular, C and D are both perpendicular to the same thing, then they have to be parallel to each other. So if one transversal is perpendicular to two lines, then the lines themselves have to be parallel. So what's happening is C and D have to be parallel. It was also called the Two Perpendiculars Theorem. D is perpendicular to A, so I know that that's just given. Okay, it's right here. So what they did in this proof, kind of unique, is they split up the givens. So this is just given. Then number 4, C perpendicular to A. So that's what I wanted to say. If I make this line go a little bit longer, then I would know, or that I want to prove that this would be another right angle. Okay. The only theorem we haven't done yet here is the 3.9, the perpendicular transversal. So if you make C a little bit longer, this is going to have to be a right angle. Just a recap of the 3-4 notes, this perpendicular transversal theorem, it's saying since these lines are parallel, C and D, any line that's, if it's perpendicular to one of the lines, this transversal, if it's perpendicular to D, it's got to be perpendicular to C, since these two lines are parallel anyways. So that's just a little bit of a 3-4 review. All right, I think this is the last one from 3-4. So in a plane, B is perpendicular to D, and D is perpendicular to A, so that's going to be my given this time. This one's going to be pretty similar. I want to say A and B are parallel, so this line and this line. So you see these right angles. I could do something with converse of corresponding angles. And then this one's actually only one more step, so I crossed off step 3. This is true because of that same theorem we were just talking about. So since these two angles are, since these two lines are both perpendicular to D, they have to be parallel by the perpendicular transversal. All right, let me get rid of this stuff first. Number 8, what's given to us is just that we have a triangle. What we want to end up saying is that the exterior angle, this one, angle 4, is equal to 2 plus 3. I need to be able to add those two angles up, and let's do that a little bit differently. I need to be able to add angles 2 and 3 up, and then get a total of angle 4. We're going to prove why that works. So let's look at each one step by step. Angle 1 and angle 4 are supplementary. Here's angle 1, here's angle 4. Why are they supplementary? Well, because they form a straight line. They're a pair of angles that form a straight line. That's the linear pair postulate. Step 3 says, okay, what does supplementary mean? We just said supplementary. What does that mean? 1 and 4 are supplementary. What does that mean as far as what they add up to? 180. Angle 1 and angle 4 have to make 180. Definition, yeah, so then now look at step 4. Angle 1, angle 2, angle 3, those have to equal 180. Well, 1, 2, and 3, well, those are all inside of a triangle. That's just how many degrees are inside of a triangle. It's called the triangle angle sum theorem. Okay, and then lastly, or kind of finishing up this proof, now I have two things that equal 180, this chunk and this chunk, kind of a transitive idea. I'm going to take these two things. This was equal to 180, now that's here. And I have that this part equals 180. And, oops, wrong one. This also equals 180. I'm just setting the green and the yellow equal to each other. Since they both equal 180, I can say that they equal each other. So since the yellow equals 180 and the green equals 180, yellow has to equal green. Kind of a transitive idea about substitution. Well then, what I want to say is here, what's extra right now is these angle 1s. I want to get rid of these angle 1s. If I subtracted both sides by angle 1, then I would have exactly what I needed. So subtracting angle 1 from both sides cancels that out. Last one. So we have our given here. Let's look at the picture for why angle 1 is congruent to angle 2. Well, those are vertical. 2 and 3, why are they supplementary? Well, what type of angles do we have? So we have parallel lines going this way. I'm sorry, parallel lines going this way, and a transversal here. These two angles are on the same side of the transversal, and they're in between L and M, the parallel lines. These are same side interiors. 3 and 4, why are they supplementary? They're also same side interiors for in between A and B. Why is 2 congruent to 4 then? Okay. Congruent supplements theorem is what we had talked about a little bit earlier in the chapter, but what we have is we have both 2 and 4 are supplementary, to 3. Since 2 and 4 are supplementary to the same thing, they have to equal each other. And then we have one step left, transitive. Angle 1 is congruent to angle 4. Well, let's look at what we have. We have that 2 is congruent to 4. We also have from the beginning that 2 is equal to 1. So 2 is equal to both 1 and 4, which means they have to be equal to each other. Again, transitive. Feel free to ask your teacher about any more of those. I'm just going to end the video with a little list of everything that was in Chapter 3 that's worth putting on your note card. So the things from 3.1 through 3.3, all that vocab, corresponding, alternate interior, alternate exterior, same side interior. Know which one of those are congruent and which one of those are supplementary. Know what the converses of those are and why to use them and when to use them. 3.5 was all about triangles. Inside of a triangle is 180. Know what to do if you have exterior angles of a triangle. And then 3.7, 3.8, you're going to practice that a little bit more today, but all of the slope stuff. Know the slope-intercept form and the point-slope form. Know what's true about parallel slopes. Know what's true about perpendicular slopes. And then again, share your note card with a teacher if you want to check what they look like and what they're missing. Okay, that's it for this video. Thanks for watching.